Mute myself. Share screen. Okay. So you guys should be able to see everything. So this is something separate I was kind of doing. So I wanted to make sure that our circuit was going to work properly for 4 LEDs. The original design, I had actually found this online, was only 2 LEDs, and I added 2 more because I wanted one on each corner. So I actually had to make some adjustments to our circuit. So the first off, the control voltage on the 555 timer. Oh, and if you're wondering, this is called LT Spice. It's a company called Linear Technologies. I like LT Spice because it's free, and after I graduate and finish school, I won't have multi-sim anymore or any of the nice fancy features. So I wanted to get used to a software that was free. And then it's also kind of convenient to use, like running it and stuff is it's pretty easy. And then like probing it. So I'm looking at the current right now. This waveform is the current through each of these LEDs. And so now I got about 14 milliamps, which I think will be plenty for the application that we're going to use this for. And then also we want to stick to using the 3-volt battery. So what I did is I basically decreased the resistance here overall. So if we go back to the KeyCAD schematic, we're going to make some changes. We're not going to have that resistor, and this is going to be a 10K resistor. Another change I made was that this control voltage, I originally had it connected to ground. Do not do that. It will not light up if you do that, or at least it will light up and then dim really fast. So this is actually a no connect, this control voltage. You have to update it every time. Yeah. I didn't make any connections yet. Hopefully you guys didn't make any connections yet, because then it'll be really easy change. But if you did like make your tracks and stuff, oh, you know what, Patrick made his tracks already. That's gonna suck. All right, I'm sorry if you're watching this, Patrick. You're gonna have to make these changes. Based on the simulation here, I was only getting 1.5 milliamps, and the diodes require at maximum 20 milliamps. In the other project I found they had 9 milliamps. I think 14 milliamps should be plenty of current. So the whole point of this transistor is to allow more current to flow through these diodes. And then you can change the time and maybe increase the capacitance because they might blink like really fast. I don't know if maybe I should change that capacitance value to. What if we did like 10? Yeah, let me. Ooh, nope, not 10 millifarads. How about 1 millifarad? Okay, that's a little better. So what we want is it's gonna slowly turn on and then slowly turn off. And the reason, basically what we have here is at our output, we have the square wave from the 555 timer. And then this capacitor here at the base of the transistor is gonna make it charge up and then discharge. And that's what's gonna give it its glowing effect. The purpose of the transistor is just to pull more current through these LEDs. So we're getting 14 milliamps. I believe, so if I click here, oh, current's right over here. So 14 milliamps about. So I think this should work out. It's really good if you can to put your circuit in a SPICE model, because like I said, if I didn't do this before, our name tags wouldn't have worked at all. So it's good to do this. Okay. So I think this should be good. So I'm gonna save this. You guys don't have to do this. This is just something I was doing earlier. Okay. So back to the schematic. When we change values, that doesn't really change anything because we're just keeping track of the values, and then the footprint should, for the most part, be the same. Uh, Later on, we'll have to look for components online. In fact, we might even do that today, actually. Um, I preferably I would have already wanted all the components picked out, but unfortunately, I just haven't gotten to that yet. Um, so then once you've made all those changes, did everybody make those changes? Everybody that's participating? And you got it too. So this control voltage should be a no connect, and this is going to be a 1 millifarad capacitor. And I removed the resistor at the base, and I changed this to a 10K. So wherever you're, there you go. No, why did you- It shouldn't be that. Reconnected. You don't have to click the wire. You can also click the white circle. So like if I delete this line, the white circle right here, instead of going to click wire or clicking W, you can just click on the circle and then you can draw the wire. Okay. So all right. So then the next thing we have to do then is we need to go to our layout. We're gonna have to click update PCB with changes made to schematic. Click update. And then, yep, some things disappear, some things move around. And then don't worry about the back copper, just click B again and it'll reflow everything. And then, oh, it did not. What was that what was the resistor number that was right here? Do you guys remember? Yeah, but do you know it's, was it like well, 1, 2, 3, 4, 5, 6, 7. I think it was R8. Um, so it's weird. Oh, okay, maybe let's. There we go. Okay, I see. So there's an option here when you click on the update PCB, and it says delete footprints with no symbols. We remove the resistor 8, but if you don't have that checked, it won't remove that symbol. So you have to do that check mark and then click update PCB, and you can see that resistor 8 was deleted now, and that was the one we removed. And then if I click B again, it'll reflow the copper on the bottom side. So the next thing to basically do is to start making all our connections. We have our silk screen here. So this silk screen is about, let's see, 40.64 millimeters by 33.02 millimeters. Let's do that in inches because conceptually, I don't really know how big that is. So 1.6 inches by 1.3 inches. So that's how much space we have for our name, basically. So I guess we'll have to do like initials instead because that's pretty small, I think. Um, And then another thing that will have changed possibly is some of the connections for these components might be a little different. What are you looking for? Oh, this one right here.
I'm just going. Mine's like not highlighted. Yeah.
Nice. Oh, are you, okay.
Oh, you don't have to open it.
No, so the
Oh.
proper way to open it is to keep that project, then you can open. I don't know if that will. Yeah, now it's there.
Okay, so let me close out the other two.
Yeah. You might have to make the changes.
That's fine. Viewing.
We're gonna want.
Yeah, let's do the update. Check these two or not?
Yeah, so check delete footprint with those symbols and check read.
And update, right? Okay.
But it should delete the one.
And then.
Yeah. So you would click on the page. This is what we put in. This is now version 01.1, I guess I'll call it. EEE badge, circuit board. You guys don't have to do this. I just whatever makes most sense to you. It's Wednesday, right? Yeah, okay. So the first thing you need to do, Damien, is you need to go to Preferences. Go to Manage Footprint Libraries. Click on the folder. Go to where you saved the DigiKey stuff. And then instead of the symbols folder, you're gonna want the footprints.pretty. And you don't have to pick files in them like we did with the symbols. You just need the folder. Yeah, select the folder, then click select folder. I'm gonna click cancel because I already have it. And then if you scroll down, I think at the bottom, you should see DigiKey footprints. You see that? Okay, click OK. Oh, you know what? There's one more thing you actually have to do. Go back to the schematic. I'm sorry. You're on the schematic? Okay, I need you to click fill this button right here. Fill in schematic symbol reference designator. So each of these letters, like R3, well, for you it's all question marks still, right? Okay, so you did them by hand. So in the future, you don't have to do them by hand. You would just click annotate and it would fill them all in for you. Okay. And yeah, I couldn't remember the name of these, but these are called reference designators. You can look that up online if you want. There's a whole standard for what component uses what reference designator. So resistors are R, diodes are D, transistors are Q. That's always the case. Chips, like integrated circuits, are usually U, C for capacitors, and so on. There's one more thing you have to do. Click on this table looking thing. So you have to associate footprints to every single symbol that you have in your thing. Or in your circuit. I'm not going to be able to walk through all of these, and some of them will already have footprints. So if you could take a picture of this really quick, you can put in the footprints yourself while I do some of the other stuff with the other students. Yes, this importing libraries will be something you have to do for the rest of your life if you do this for a living. So the footprints are the actual like components you're going to use on your circuit board. And the footprint is kind of like the outline of the component where it's going to be. And usually they try and convey as much information as possible about the component. So for example, if we look at my board here, this component is for capacitors, and it's a dielectric capacitor, and it's polarized. So this yellow is actually silkscreen. This will actually show up on our board. And it has the two different colors, one with silkscreen, one without, to help tell you, okay, the one with silkscreen, that's your ground, and the one without is your positive lead. So that when you put the component in, you make sure that you put it the right way. And then there's also this plus sign for even further to show you, okay, positive's on this side, ground is on this other side. There's other components here, like this one kind of outlines, it tries to outline what the transistor is going to physically look like and how big it will be. So this will be about the size of the transistor when we put it in. This footprint outlines the battery holder that that we're going to use. This one outlines the IC chip. So these are all silk screens that we're actually going to see when we print out the circuit board. Move this one a little bit. Okay. So at this point, so once you finish all those footprints, Damien, then you can start on the actual circuit board, okay? So for the rest of you, we now need to just start making connections. If you notice any components that like you might want to move, like so I just noticed this one needs to connect here and this one has to go across it, across that that rat's nest line. So it would probably be better if I flip this and move it because now they won't overlap at all. And then reflow. And so I'm just gonna start going through with make sure you're in the front copper area. You can do back copper, but you're gonna ruin the plane, the ground plane. I think for all intents and purposes, it doesn't really matter for us, but just keep in mind that whatever's on the back, you can't have it touch any of these through-hole components or else your circuit's not going to work right. So the way you start this is you're on front copper, you click on route tracks, or you can click X, that's the keyboard shortcut. But keep in mind that's going to start from wherever your mouse is. So if I put the mouse on the pad here and then I click X, it'll start tracing from the pad. And then you just start making your connections and just kind of like feel it out. See what makes the most sense. See, so like I'm gonna have a hard time because I need to make this connection here. All these connections like underneath the PCB or underneath the IC are okay. There's some things you might want to keep in mind, like although this has like that's about 0.127 millimeters afar from the pad. Just to be safe, maybe just give it a little bit more distance. So the way you do that is after you've made the trace, you can select one side and then select again, like click again, and then it's really hard to do with a trackpad. So click it and then click again, but hold it, and you can start dragging the trace here. You can't click and click move, or else it will move it like this and you'll lose the connection. So that's kind of like my complaint about KiCad, because that really sucks. It looks like I might have to use the backplane a little bit, and it honestly, for this application, it doesn't matter. So the way I would do that is I would go to back copper. I'm going to go to track again. I'm going to make this connection here. And then I have to click B and reflow, and then it'll remove the ground plane from where I made that track. Just let it be known that if you're working for a company, when you do this, you hinder the positive effects of having a solid ground plane, because now some of the electric field lines, flux lines can come through this area instead of terminating on the ground. But like I said, I don't think EMI is a big worry with this circuit that we're making. So I'm gonna go back to the front copper. I'm gonna try to keep as much of it on the front copper plane. Notice that none of the ground connections need to be made because the back copper plane is already connected to it. All these pads are on front and back of the board as well. So that's something else to keep in mind. So I need to make this connection here. So for example, I'm going to move this trace a little bit to give me a bit more space. Here, and then I can run this track. If you want to give it like a specific path, like it'll try and auto predict and connect for you. But if you want a very specific path, I can click and it will stick like the section that's behind it. So if I click again, it'll do that segment. If I click again, it'll do this segment. There we go. And then maybe right about here can come in there and then to the pad. Okay. Another thing to keep in mind is you don't want any 90-degree angles and no acute angles, absolutely no acute angles. And the reason is because part of the process of actually making the printed circuit board includes acid. When the board is dipped in the acid, if you have any acute angles in your copper traces, that acid will collect in the acute angle. And yeah, that's bad for you to touch, but the other thing is that it will slowly corrode and eat away at your copper traces, and in the long term your board will end up not working or working for a long period of time. It'll stop working. So try and keep 45-degree bends like this, and if you can at all avoid it, don't do 90-degree bends. Try to keep them all obtuse. So this angle right here is an obtuse angle, that's an obtuse angle. This is an obtuse angle, so no 90 degrees and no acute angles, if you can help it. 90 degrees is kind of okay, but definitely no acute angles. That's not what I wanted. And so you'll start to see too, each of those white lines will slowly disappear as you start making your connections. Another thing you can do, I'm just going to do this because just for the sake of showing you guys, but I can't go across this copper trace here at the front because none of them are allowed to overlap. So another thing you can do is while you're making your routes, you can click V and that will, you'll see the little circle pop up on your crosshair. That's a via. If I click again, that'll create a via there and that'll move me to the bottom side copper. And then I can come up on this side and then I can make another via. I would click V again, and then that will bring me back to the front copper plane. So I can get across copper traces that way as well. You know, and I didn't spend a whole lot of time trying to figure out how to best place all these components. That's maybe something you can spend a little bit more time with if you want. But it's not going to make a huge difference in how this circuit works. If you had something with like specific signals on each of your traces, then it might be more important for you to consider maybe rearranging your components so that it'll connect better. But you had a question, Damien? Yeah. So it will only let you connect with the white lines. You see how it highlights each of the pads? It physically will not let me make wrong connections. And all the connections are based off the circuit diagram that you make. There is auto routing. I'm gonna get to that later. There's good things and there's bad things about auto routing, and I'll go into detail later about those things because most auto routers, they have no idea what your traces are. So it doesn't care if it takes a signal trace and runs it all the way around the board to make its connection. That's going to create a very large loop. That loop is going to act like a receiver and it's going to receive electromagnetic waves and add noise to your signals. And so that can be a problem depending on the application of your circuit board. Another nice thing about through-hole components is I don't have to make a via off of it, whereas a pad, you would have to start from the front, move a little bit away from the pad, make a via, and then you go to the back side of the board. But since we have through-hole, I can just start at the back copper, go to my tracks, and now I can make this connection on the back copper if I want to. And then just reflow. And then last connections over there. So I'm gonna go back to front copper. You probably could have done all this without going to the back plane if you spent a little bit more time rearranging everything. I just didn't get to it, unfortunately. Another thing you might notice is it has this specific distance between tracks. So that's that parameter that we set a long time ago to not let these tracks get too close. Because in our case, JLC PCB won't be able to manufacture these PCBs if we make them any closer than the clearance setting that we set in video 2, I think. Lecture 2, whatever you want to call these. There's no really easy way to do these LEDs, so these are gonna go way up here. There's no concern with the oh wait, for like between here? Yeah, so you should be fine. I'd actually be more concerned about like arcing or anything. That's usually why I move them, but you don't have to worry about acid or anything in that case. You just need to make sure you don't have very acute angles or tight angles. Let me see if I can try and Like anything like that is a, so that's a 90-degree angle. That's bad. But anything more acute than that is even worse. Like something like this would be really bad because you're gonna get acid buildup here, and then that's gonna eat away at your copper trace there. What's up? Sure. You need me to, okay. You can arrange your components however you want, but make sure you have this silk screen layer here, because this is going to be where you write your name. So you'll have to go to the front silk screen layer, and then you're going to click on the square again, and then click on the corner you want to start on. I'm going to do it outside the circuit board, but you're going to want to do it in the circuit board, of course. Yeah, well, there's no specific size. Just make it as big as you can while fitting on the board, because that's where you're going to write your name. And then while you still have it selected after you place the square, click E, and then you got it open. You click on filled shape and click OK, and it'll fill in the square for you. So now, if we can actually look at our boards if you want. If you click on View and then click on 3D Viewer, this is what we got so far. So they use red LEDs because that's all the only 3D model KiCad has. But this is kind of what we got. So this possibly isn't I didn't have the 3D model for this one. It's actually going to be a smaller component. And then I couldn't find the switch model, the 3D model, but this is what we got so far. Here? Yeah, it's fine. Yeah, I'm probably actually gonna move these LEDs down. Or yeah, or maybe we could put the IEEE logo there. You think we should put it there? Or do you think we should put it on the backside? Because we could put the IEEE logo there too. Yeah, I feel like maybe it would be better because you show your name and then the organization. We could, if somebody wants to design a 3D case for it, they can, but I literally intended on wearing this circuit board on. I was literally gonna put it on a lanyard or strap it to my book bag and walk around with it. It doesn't have to be green either. We can pick different colors as well. Black, yep. Well, how about blue? Well, then the IEEE logo would have to be a different color, but we could do black IEEE and then a blue board, or maybe a little bit. So, not silk screen is only white. So all the silk string is going to be white, but on KiCad it's a yellowish tint, but this is actually just going to be white. So that's only one color, but what we can change the color of is the board. So here, if we do JLC, we have options of green, purple, red, yellow, blue, white, and black. Yeah, it's going to take an extra few weeks to manufacture, but this is for. There is none. This is going to cost like $2, maybe like $10 for 100 boards. Like we could literally mass produce this for dirt cheap. Yeah, I'm thinking. What do you think? You like blue better, or you like? Yeah, I know. I want to make it. I want to make one too at some point. Maybe next workshop I'll have it as like a simple project. If with your permission, Andrew. All right, cool. Okay. That looks like a business. Let's play it. It's not even 1 inch. It's not even 1.05 inches. Oh, is that a green? Oh. Yeah, no, it's everything's small, short, small voltage. Just don't go crazy with it. Keep a little bit of a distance. It's something that that makes you feel comfortable with your circuit, you know, because you don't want any short circuits either. Where we at? We got 16 minutes, so did you guys finish connecting everything yet? Or okay. So you would start the trace and then you click V and it'll add a dot where your mouse is, and then you would click, and then once you've clicked, you made a via now that goes to the back side of the board, a through hole via. And then you just click V again to go back to the front layer. I want copper, and I'm gonna connect this. Oh no. If you guys place a via and then you want to reposition it, if you select the via and then move, it will automatically adjust the tracks for you too. But same thing, if you click M, it won't move them for you, and those aren't going to be connected anymore. So it's something to keep in mind. Unfortunately, KiCad does have a feature when you press G to drag, but then you might get like really nasty angles. Like this one would create an acute angle if I would put it right here. Right. And then it also doesn't have the nice 45-degree bends and stuff. So hopefully they fix that. You know. What do you mean they suck?
That's,
But if I go around that way though, then this connection is going to need vias.
I'm saying, all the way up.
Well, yeah, you're right, but I don't. I mean, it really doesn't matter. It really doesn't. Well, why are you against having extra vias though?
Oh,
Maybe.
another point.
Ah, okay. Well,
There's that other,
layer.
yeah,
No pun intended.
if you don't need it.
All right, sure. There you go. And again, don't forget that this net is overlapping with the ground pad, so make sure you click B to replace the ground copper. It should be okay because the silk screen is going to overlap. You know what? Let me.
the front.
It'll go on top of the trace. So here's our trace right here, and the silk screen is going to be on top of it. So you effectively won't be able to see the trace actually because of the silk screen.
Okay.
Another useful feature of KiCad is whatever layer you're on, it will overlay with that with the top. So like if I go to silk screen, it'll show the silk screen at the top. If I go to front copper, it'll make the front copper on top so that I can see the different layers. What's up, Lee?
No.
No worries. Yeah. Although one thing to keep in mind is if you do vias on the silk screen, then you're gonna have a hole on your silk screen. Yeah. The hole is going from the front to the backside. That's a through hole via. So they literally drill a hole from the front to the back of your board, and then they fill in the hole with copper so that you can make connections to the back of the board. Right, right. So if you make any vias that are on that, then yeah. You need which line? Okay. Yeah. Yep. We'll get there. I'll show you guys how to do that. No worries. Right. All right. So right now I have all my connections. I'm still not sure if this is enough space for carabiner. I don't know. What's up? What are you having trouble with, Damien? Okay. So then if we go to view, we can see this is what it looks like so far. Okay, and then the only difference is we're gonna have blue LEDs. This IC isn't gonna have these bends, these weird bends like that. That was just the 3D model I found. And then we'll probably have a different battery holder. But this is basically what we're gonna have. Oh, you know what I should have done? I should probably. Okay. Now this is where things get messy. And I probably should have made this change before, and I'm sorry. If you move your components, you're gonna have to delete the tracks and then move the component. And I'm just gonna line these. I can't believe I didn't do that, but I'm gonna line up the LEDs with the silk screen because it's gonna bother the crap out of me if I don't. Yeah, right. So you don't have to, it'll just look nicer so that they're on all the corners of the silk screen I made. No, that's the challenge of PCB design. Well, you started without asking. I keep clicking. I'm sorry, guys. I keep clicking the home button instead of. What do you mean? I don't understand what you're. That depends how far you want. There might be so like you're gonna have to might affect some things with your circuit. So it's always safer to have a little bit of action. When you're making recommend that. Okay. So we have all our connections now. I'm gonna go to view. We can see what it looks like. So that's a bit nicer. Now it's on all four of the corners. Here's what the back side looks like. You can also click this right here. It'll flip it from the front to the back for you. And then if you click here, it'll take you back to like a home position, kind of. Okay, so the last thing I want to do is we're going to go back to the front copper layer. And I want you to just go through all your components and make sure like here, the D1 silk screen for this diode, it's overlapping with the other silk screen we had. That's a problem because we can't overlap silk screens. It just won't appear. You won't see it. So go to all your components, click on the letters, and then click move, and just move it somewhere reasonably close to that component. And that's just so that when you look at the board, you see, okay, this is diode 3, this is diode 2, diode 1, and so on. Make sure that they're not under the component either, because I can put this in the courtyard inside of the purple line, which is called a courtyard. But then when I solder the component on, I won't be able to see it anymore. So that can be annoying when you're trying to troubleshoot things. I'm trying to line these all up here too. If you're on a trackpad, it might be a little bit easier to just click it and then click M. That's usually what I do. Try and make it symmetrical and nice. Sometimes, like this plus sign, I won't be able to move because this plus sign was made as part of the footprint, whereas C2 is just the identifier for the footprint. This was made as part of the footprint. So if you wanted to move that, you would have to click the component, click E, click on Edit Footprint, and then it'll pull up the footprint editor, which we didn't do a lot of work with because we didn't custom make any footprints. But you'd have to go here and then go to both of these crosshairs and then move them this way. And then that would let you move it. But I'm gonna leave this alone. I'm not gonna change it. I just wanted to show you guys what I meant. So that is part of the footprint, whereas C2 is the designator for that component. C1, I'm gonna put over here. U1, it's gonna go right here. Okay, and then one more thing I want to do is I want to add the IEEE logo. So you can actually add footprints directly to this. We could have done this without a schematic, but I wanted to walk you guys through that process because every company does it that way. But if you click A, just like you would when you're in the circuit editor, you can select different footprints here and you can put them straight into your circuit board. I'm going to go to, should be logos, symbols here. And these are just silk screen. There's no pads or anything. So this is where we would put our logo. So what we can do is we can actually import a footprint and just make it all silk screen. So I have to remember how I did that. Are you talking about this in the project?
Yeah.
Okay. Oh wow. Okay, so I actually didn't know about this. Okay. So one of the things you have to keep in mind though is do you did you find that it works with other file types or it has to be a bitmap? Okay, then I'd have to. Yep. So then I would go to KiCad projects, imported libraries. I guess I'm gonna make one for logos. Then I'm gonna call this IEEE logo. All right, let's see how that looks. I actually have no idea how big that's gonna be. Oh, um, actually, hold on. I might have to import that. Mm. Huh. Oh, that's right. That's right. I don't know what to name it. I'll just call it IEEE logo for now. And then here, that's right. Okay, so if I just select logos, now that should be imported. So then I can go to IEEE logo. Hey, look at that. It's pretty cool. That's pretty cool. That's not silk screen. So that is oh, it is silk screen. Um yeah, we can just delete it. Should be able to. Oh no, apparently not. So you can't delete designators. I wonder, so did yours not have that? Okay. I wonder if I can. There we go. So just change it. So if you click on the G, then click E, and then you can change it to a different layer. I recommend user comments, and then that will not show up on your board. Only the silk screen shows up on the actual board. So now if I go to 3D viewer, doesn't show up. What did I do? No, silk screen. I don't know why it's not showing up because that's on the front silk screen layer. Huh, it's not recognizing it. All right, I'll have to mess around with it a little bit, but the last thing I want to do is I want to get the IEEE logo on there. And then I guess next week we'll we'll go through the ordering process. I'm gonna plug in, um, I have to request the order through Student Life and then they approve it and everything. But I'll find all the components and then we'll place an order for our boards and then we'll have name tags. And then after that, we'll learn a little bit, few extra features by creating the ESP32 Developer Kit. I plan on making about 5 of them, so I'm gonna give out the dev kits to a select few. And then yeah, and then that's the end of the workshop. So uh thank you guys for coming today. I think that concludes our workshop today. I'll go ahead and stop the recording and I'll start uploading this right now. Have a great day, guys.